The first seasonality model that we're going to look at is the double exponential smoothing model. So it's called a double exponential smoothing model because we'll look at both a level and the seasonality. And so we're going to introduce seasonality as a multiplicative seasonal term. So my underlying model is going to be this: demand in time t is equal to the level, which we can think of as the average demand per period, multiplied by the seasonality index that's appropriate for that particular time period, f sub t. And then we're going to add in our old random variable where we expect that to be the noise around the expected value. We expect a value of that random variable we say is 0, so it's not biased, and we have some kind of variance, just like normal, and it's IID. So let's talk a minute about that f sub t. So let's look over here at this right table where we have the seasonality with time, and let's say this is time period 1, this is time period 2, 3, 4, and you can see. And so I've got every time period, it's like a 2-period seasonality. I've got a low period on the odds and a high period on the even periods. Let's say that's my seasonality, odd and evens. And so down here, let's say this value is 0.5, or half of what the average demand is. If I averaged across, that's what that dashed line is. And up here, it's 1.5. So what would that mean? That would mean that f sub odd is going to be equal to 0.5, while let me clean that up, while f sub even equals 1.5. Okay, so if we make sense, right? Because if it's half the time, then it has to be 1.5 the other half of the time. So you'll see what this means is that the sum of those seasonality indexes for one full season have to add up to the number of periods in the season. In this case, the sum is 2 because we have 2 seasons, or 2 periods in the season. You can also look at the average, and the average will always be 1. It has to average out. Okay, so keep that in mind, and we'll keep going. So my forecasting model is going to look very similar to the underlying model, like it always does. So the forecast, or the estimate for the demand made in time t for time t plus tau, so I'm going tau units in the future, is going to be equal to the estimate of the level made at time period t, at the end of time period t, multiplied by this factor, the seasonality index, and it's t plus tau minus p. Now we'll talk more about this in a second, but essentially what it's doing is looking at the most current estimate of the appropriate seasonal index. So if I'm in an odd period, it would look back to the most recent odd period where I estimated that seasonality index. And we'll talk more about this in the next slide, but just think of it as being the most recent estimate we have. Then, because I've got 2 patterns, I've got 2 updating procedures, 2 variables that I need to constantly update: the a, the level term, and the seasonality term f. So let's look at the a term first. Again, it's like every other smoothing function. I've got this alpha term, goes from 0 to 1. So the estimated level, let me go back. Estimated level of demand in time period t is going to be alpha times my new information plus 1 minus alpha times my old information. Now my old information we should be familiar with. That's the estimate of the level from the previous time period. The new information, think about what we're trying to do here. We're trying to see what is the average demand going to be with this new information. So what I'm going to do is de-seasonalize it. I'm going to take that actual demand, xt, this is what actually happened at time t, the actual demand that showed up, and divide it by the seasonality index that's appropriate for that time period for the most recent estimate of it. So that's f hat t minus p. So I'm de-seasonalizing it because I want to see, okay, if it comes in as on an odd day, it's way down here, right? But I say, okay, if it's only half of a typical period, then I'm going to divide it by 0.5 to get me up to here to find out what that average is, because I'm trying to find an estimate of the level. So I'm de-seasonalizing it. We'll spend a lot of time talking about this more, doing some examples. The last term, is the estimate for the seasonality index, f hat sub t, and it's going to be equal to gamma. Gamma is our smoothing variable here, and it goes between 0 and 1, just like the alpha and the beta for the other smoothing terms we've done. So it's going to be gamma times my new information. That's xt, which is the actual demand that materialized in time period t, divided by the estimate for the level in time t that we just did. We just did that up here. So what am I doing here? Well, I'm de-leveling the seasonality, the actual demand now. So I want to take out the level and see what if this told me anything about any new seasonality. And then I'm going to add to that 1 minus gamma 1 minus gamma times the seasonality index of the most recent relevant period. Okay, so let's dive a little more because people get confused because of the nomenclature. And so the one thing that I think is helpful is to think about this multiplicative seasonality factor, this f sub I, as the percent of the average demand for that period I. And remember, the sum of all the fi for all the periods within one season must equal p, which is the number of time periods within the season. So let's talk about the sandwich shop where we also sell bagels. And what I've got here on this chart is a time period 0 to 114, and every day is labeled. So we've got 3 weeks here, right? And I'm closed on the weekend, so it's a 5-day week. So my seasonality has 5 periods in it. So I think that every week has a certain season. So suppose I didn't have any seasonality and that it's just a level. It's just a simple exponential smoothing model I'm going to use because I think the demand is level. Then essentially all we're saying is that the seasonality index would be 1 for every period because it's the same. So you see that would still add up to p, right? For 1 week I would add these up and that still adds up to p, and the average is still 1. So that fits. That's okay. But suppose instead we had seasonality like this. And you see Monday sells half the average daily number of bagels, while Friday sells 50% more than the average. And if you look at these, you can see they sum up to 5 and the average is 1. So what would this look like? Something like this. Let's see the green diamonds. And so you see it's a repeating pattern. It's seasonality over the week. So remember, our forecasting model is this x hat t comma t plus tau, predicting from today for tau days in the future, and that equals the estimated level in today multiplied by the most relevant seasonality factor. So what does that mean? That f hat t plus tau minus p always confuses people. So let's do an example. Suppose we're sitting in Monday, time period 105, and I want to forecast for Thursday, t108. So what is going to be f t plus tau minus p? Well, tau is going to be 3 because I'm going 3 days in the future, right? 1, 2, 3 to Thursday. What's my p? My p is 5, so I'm going back 5 days. And where does that take me? That takes me to the most recent Thursday that I've estimated. So the x hat 105 comma 108, which is the estimated demand made from period 105 for period 108, is going to be the estimated level I made in time period 105 in Monday, plus the seasonality index that was last estimated in time period 103, which was the last Thursday. Since I'm forecasting for a Thursday, I want to say, okay, what is the most recent update or estimate of a Thursday seasonality? And that's what I apply. So you can think of it as what we do is modify the most recent estimate of the level by the most recent relevant seasonality index. And by relevant, I mean the same type of period. A Monday to a Monday, a Tuesday to a Tuesday, and so on. So let's do a quick example. We're in our sandwich shop. We got bagels, and we're sitting in Friday, time period T104, and we've estimated that the level demand is 121 bagels. So that's on average, I sell 121 bagels a day. You know, a little less on Monday, a lot more on Friday, whatever, but on average, I'm estimating I'm selling 121. And here's the seasonality factors are in this table to the right. And I've got a smoothing factor of alpha 0.1, gamma 0.05. So what's my forecast for time period 105? So sitting in Friday, right, I want to make a forecast for the next business day, Monday. So that's time period 105. So my tau is just 1, right? I'm going 1 day in the future. So there's our forecasting model. So we're looking for x hat 104, 105. So it's simple. It's going to be the level estimated at my time period 104, which I gave you up here, 121, times the most relevant seasonality factor. So that's 104 plus 1 is 105, minus p is 5, means it's going to be f hat 100, which is 0.5, my last Monday. Makes sense. So 121 times 0.5 is 60.5. That's my estimate for Monday. I'm estimating, due to seasonality, I don't sell many bagels on Monday, I'm going to sell 60.5. That's my forecast. Suppose now Monday happens and you had a bang-up day. You had a great day, you sold 76 bagels. So more than you expected. That's okay, you had extras lying around, you had safety stock. So the question now is, what's your forecasted demand for Tuesday? So I want x hat 105, 106. Well, I'm going to use a spreadsheet because we're going to be using these more and more. So what do I have here? I have the alpha and the gamma terms in cell C1 and C2. Then here's my current seasonality factors in column E from cell E5 to E9. And then all I'm going to do in cell D10 is calculate the level in time period 105, because I need that to determine my forecast for period 106. And that's simply alpha times the actual demand in time period 105 divided by the seasonality of the most recent estimate. Now, I'm doing a level here, so what am I going to divide it by? E105. It's a Monday, right? Because I want the level, I'm de-seasoning it by a Monday seasonality factor. And then I'm going to add to that 1 minus alpha times D9, and where D9 is the most recent, or the most recent estimate for the level, which is 121. For the seasonality, I have the gamma times, I'm de-leveling here, C10. What is C10? The most recent estimate, or the most recent demand that came in, divided by D10. What is that? What I just calculated, the most current level estimate. I'm going to add to that 1 minus gamma times what's in E5. What's in E5? Well, that's, again, the Monday, because I'm estimating what is the seasonality at Monday. And then to find the final estimate for going forward, I'm going to take the estimated level, so that's in cell D10, right here, and I'm going to multiply that by what? I'm going to go f hat t plus tau minus p. Where is that going to take me? That's going to take me up to cell E6. Why E6? Oops, let me get that. Why E6 and not E5? Well, this is a forecast for a Tuesday, and so I want to use Tuesday's seasonality. And so if you look at the numbers, they work out. And so calculate the f sub t, because we're doing 105 plus 1 minus 5 is 101, which tells me Tuesday. All right, so hopefully you saw the mechanics. Just pause the video if you need to, and you can see what the cells do. Do this in your own spreadsheet. But I want you to notice something. Our seasonality factor changed for Monday. It went up a little bit. Makes sense, right? We sold more than we expected. So what we have to figure out now is, well, is the level going up or is the seasonality changing? So what the exponential smoothing is doing, it's upping both of them. And you'll see that both the level estimate went up a little bit, quite a bit actually, by 3 bagels, because it's saying, hey, new information, maybe we have a new level now. But also it's saying maybe Mondays aren't as bad for selling bagels as we thought. So what we have to do now is normalize those seasonality indices, and we'll do that in the next video.